good afternoon. I am Anwar Jacinto Moreno, and today we'll be going over the topic of polarity, which is the basis for paper chromatography. Paper chromatography consists of a stationary phase and a mobile phase. The stationary phase, the paper medium, is composed out of cellulose, and if we look at the structure of it, we can see that it has polar and non-polar components to it. But due to the large amount of hydroxyls and oxygen atoms in the structure, it's going to have an overall polar character. So if we use the different combinations of solvents, which are the mobile phase, then we can have a different environment in our paper chromatography. So as the solvents travel through the paper medium by capillary action, that's going to be the mode of action, or the force is going to be enabling our samples to move through the paper. Now, the rate of movement for this chromatography depends on the attraction between our sample and the polar stationary phase and whatever solvent we introduce to the chromatography, whether it's a more polar solvent or a non-polar solvent. So today's overall objective will be to run the paper chromatography with our different samples. We want to see if our substrates or samples, if they're more of a polar or non-polar compound. All right, so let's go ahead and get started with today's experiment. All right, and for the next part, before we begin the experiment, let's make sure we have our personal protective equipment, like our lab coat, gloves, and goggles. And of course, we want to have our pants covering our ankles and toes. Let's get started. For this experiment, you'll be using a beaker with a wash glass for every different type of solvents that you'll be testing, a 10 milliliter graduated cylinder, filtration paper with a ruler, scissors, and a graphite source, and of course your different types of ink sources or the sample that your TA has provided to you. For today's chromatography, we're going to be using hexanes, which is a very good non-polar solvent, and ethanol, which is a really strong polar solvent. For the paper chromatography experiment, we will first be making our chromatography strips. So these are made from filtration paper, which is here. And what we're going to do is we're going to mark a straight line at the top of this paper. And you want to get an idea of the length of your line. So I have here from 2 to 12 centimeters. I'm going to look for that 2 to 12. Get it somewhat straight. Mark a line across. We want to measure at the top 0.5 centimeter from your marking. 2 different places so that we can get another straight line. At the bottom, we're going to mark it 1 centimeter from the line to the top. 1 centimeter and 1 centimeter. We're going to connect our dots and make another straight line. So the line at the bottom, the one that's 1 centimeter from the lower marking, that's going to be where we will introduce our sample. So now you can cut a straight line. So it's going to look like this. And you make straight cuts, and this is what you get. All right, for this demonstration, we're going to be using ethanol and hexanes because the polarity between these two is very, very different. Ethanol is an extremely polar solvent, and hexanes is very non-polar. So we're going to do a quick demonstration using 2 different ink sources. We have a permanent marker and an oil-based pen. So it's going to be really easy to mark the spots using the pen. All right. You want to do the marking at the center point of the bottom line. For the permanent marking, you want to be extremely fast and light with your touch. You do not want a giant big spot. You want to do the smallest marking possible at the center of the chromatography paper. Just like that. We're gonna do the test with one strip with a permanent marker and one strip of the oil-based pen. They're both gonna go together in the beaker with ethanol and likewise for the beaker of hexanes. First, we're gonna pour our ethanol. And it helps if you have tweezers, or you may fold the chromatography strips lengthwise so that they're easier to stand. And you want to make sure that the solvent level is below the bottom marking of the chromatography paper, because you don't want the sample to go into the solvent. You want the sample to travel on the paper through capillary action by the movement of the solvent molecule.